tonight's topic is 10 things you should know when discussing evolution. This month's theme is no mistakes. Last week we talked about how we're different, how we're created different. We're different from the animals, different from the angels. We're different from the plants and everything like that. We've been given a soul. We interact with God. And redemption is available to us, basically. You know, Jesus didn't come and die for the angels, even though a third of the angels fell. Like, that's not what Jesus did. So, tonight we're going to be talking about the next thing, which is evolution. You guys all know about it in school. You've heard about it. No doubt it's taught in your science classes, evolutionary biology. So tonight what I want to do is I want to equip you with 5 of the 10 things that you should know when discussing evolution, all right? So if you have a paper, you have a pencil, write this down. The first one is this: science does not mean evolution. Okay, I'm going to say it again. I know that this is kind of like no duh, but I needed to hear this whenever I was your age, and I need to hear it oftentimes, because when I hear the word science, sometimes there's like this fear that gets in me, like, but listen to it again. Science does not mean evolution. A science class may teach evolutionary biology, but by no means is that the definition of science. When you go into your science classes at school, they might teach that theory, but that is not the all-encompassing science. That's what science is. Actually, the definition of science is this: the systematic study of a subject in order to gain information. So science is basically when you look at something, when you make observations, you even know about the hypothesis stuff, you know. You make a hypothesis and you test it, and it's observable. This is for anything, all right? Science is just the act of looking at something. So we commit acts of science all the time, basically. You look, right now, you're observing me, and you're making judgments. You're saying, okay, he is a Caucasian male who is redheaded, who burns easily, because he is super red right now. I went to the retreat, or not the retreat, but the outreach, kids jam, and my flip-flops, I don't know if you can see this or not, but that's my sunburn. Anyway, I'm going to shed these things because it's just cool, man. All right. It's just cool, man. Groovy. Groovy. Take your shoes off. All right. So science. That's what science is. Now let me give you a definition of evolution, because there's a difference. Okay? Evolution is a theory in science. So someone made an observation, and they come up with this theory, and this is the theory of evolution: that all life on Earth has come about through descent with modification from a single common ancestor. So we all came from, you know, this particular thing, and now it's all spread out, and you had Darwin's tree, right? That's what evolution is. So when you hear the word science, what I don't want you to think of is that the only thing in science that you can believe is evolution, because evolution is just a theory. So that's the first thing you should know whenever you come to this topic of evolution. Whether it's in your classroom, whether it's with your friends, whether it's with anything, or whether it's just in your thought, the first thing you should know is that science, it does not mean evolution. All right? The second thing is this: there is a battle of worldviews. I'm going to say it again. There's a battle of worldviews. So basically what this means is that let me just give an example. If we look at this table right here, okay, I make an observation about this table. I'm looking at the same evidence. I see that it has a Bible, a phone, and a paper on it. Okay, I see that, you know, it's made out of glass up here, and there's some writing on here. So you're looking at it from down there, and you're seeing all this. There's some things that you don't see necessarily, but that I'm making observations of, and I'm sure there's things that I don't see that probably you can see better. Like I can see that there's fingerprint marks on here. I'm a little bit closer to it. But anyway, we're looking at the same thing, and we're making different observations about it. Some of them, no matter what observation we make about this table, we're stating true things about this table. All right? So where's the difference? When you think of science, why is it that evolution is a word that is so commonly used when it comes to science? Why is that? It's because of this. It's a battle of the worldviews. I, being let's say a Judeo-Christian, okay, that just means I'm a Christian, okay, that come from, kind of Jewish roots. I'm not Jewish, but basically I believe that Jesus Christ is the Messiah, that he's the only way to heaven. There it is, and let's say that there's someone over here, and they are what we call a naturalist, which means that they don't believe in God. I'm over here. Let's just not even say that I'm a Christian. Let's just say I believe in God. So I believe in God, and now this person doesn't believe in God. Do either of these people know if there's a God? I mean, that's debatable. You could say, no, we're both kind of just coming with our our assumptions, our preconceived ideas, stuff like that. So what we naturally do is we observe things like this table. I'm going to change the table now. I'm going to change this to something else. Let's say like a tree. We observe a tree, and because of our preconceived worldview, or our idea of the way that the world works, who God is, what the making of the world is, we bring our own assumptions into the evidence. We're all looking at the same evidence, but we're coming up with different conclusions. We're making the same observations, but we're saying different things. Like, if I put my finger right here, I look at it and there's a fingerprint, I'm going, I think that, that looks like Nils' handprint. And if I put it over here, I think that handprint right there is probably Jeanette's. I think she's been up here before. And now I'm making observations about this thing. But then you're like, no, Jeanette has never touched that table. This is obviously, and then you're like, okay, you idiots, why don't you just look at the fingerprint and test the fingerprints, you idiots. Okay? So it's all about the battle of worldviews when it comes to science. Okay? The naturalistic worldview, okay, someone who believes that there is no God, that matter is the end all. This is what the naturalistic worldview says, that there is no God, that scientific law is adequate to account for all phenomena. Did you hear that? There is no God, and that all we need is scientific fact. If it's testable by like science, if it's testable, then it's true. So that's a naturalistic worldview. That matter is the end all. That you can only know something if it's observable in the realm of like matter, like things that we can touch. Now this is the Christian worldview, or let's say a theistic worldview. You don't have to be a Christian to hold this worldview. That there is a God who is outside of scientific law, who created the law of science. So you can imagine us coming with our ideas of what God is, who God is, and what that looks like, and what the makeup of the world is. You can see that obviously there's going to be disagreements about the things of nature. Obviously. Before I go to the third thing, I want to say this. Notice something. I taught you guys a couple months ago about different worldviews and about self-defeating statements. And I just wanted to see if you guys could catch this self-defeating statement in the naturalistic thinking. Okay, this is it. Scientific law is adequate to account for all phenomena. That's good. Whenever I heard this, I was like, their statement that everything that you believe should be tested by scientific theory, their statement is not tested by scientific theory. The statement in itself is a preconceived idea. It's a thought. It's not something that you can grab onto. It's kind of like this, just this theory, just this thing. It's outside of the scientific realm. You can't test that statement. So, I was like, well, that's just a self-defeating statement. That's just one thing I noticed, okay? So listen, the third thing that you guys should know is this. That with science not being evolution, that there's just different worldviews as people look at it, as there's this going on, I want you to know that there are things that they say, that these people say to these people, and that obviously these people say to these people about what they believe. And one thing that we hear charged against us oftentimes is this. As a theist or someone who believes in God, that God created things, that there's intelligent design in science, we hear this often. It's this: God is a crutch to you. You believe in God because you can't explain things. And me, I'm over here, I don't even believe that there is a God. I believe that all things can be explained. Give me enough time to study it. You know what? What you are is you're really just a lazy scientist. Whenever you get to something that you can't understand, you go, oh, I don't know, God did it. So this is something that I guess is an accusation that's brought against the theistic mindset, the theistic worldview. And this is the third point that I'm going to make, is this. They call it the God of the gaps. That means when there's a gap, you fill it with God. This is my third point, is we don't have a God of the gaps. It's really simple. We do not have a God of the gaps. And here's what I would say to that. Is there's two things I would say that I want you guys to remember under this point. The first being this, that historically, this idea has never been the case. I'm going to throw out some names and see if you guys know them. How about Galileo? How about Kepler, Pascal, Newton? Okay, those are all historical scientists who believed in God. Now, they weren't perfect men, and they had probably some things that were whack about them, and you know, but they contributed a lot to scientific theory that is now. But they believed in God. And their belief in God did not stop them from contributing to modern technology, to scientific thought. Instead, these men were fueled by this, by their theistic thought, that there was a God, and that when they looked and observed things, they could find intelligent design and find information and find things that they could hold on to. It was this thought that drove them. I don't know how it's flipped around to the point where we are now, but maybe you guys can talk about this in your small groups. It's just strange to me that this is something that goes around. And when we hear it, we're like, oh, I don't know what to say, man. Well, maybe God is a gap filler for me. Maybe I just don't understand the world, so I just use God as a crutch. And it can be intimidating sometimes when you hear something like that. But that's my third point, is that that's not the case. Historically, that's not the case. And I want you to see this, that when someone says this, they're committing the same wrong that they are accusing someone else of. They're saying, man, you're closed-minded because you believe in God. You will not give an option for anything else. And what do? They end up stopping scientific progressment because they say, you know what, I've already discounted God from my mind. I'm not even going to make that an option. So what have they done? They've closed off a section of scientific thought. They ridicule it. Now, this is what I'm going to say, is that we can be guilty of the same thing. Okay, if you are a Christian in here and you're having these conversations, don't paint this person out to be a monster, please. All right? And don't get me wrong with what I'm saying. Okay, these are just things that I've heard. Not everyone is necessarily like this. But if you hear this raised against you, know this, that you don't serve a God of the gaps. And you can point to many things in the naturalistic mindset that says, hey, we're closed-minded to that idea. You know, we're not even going to give God even a glance. We know that it's by evolutionary biology that, you know, we came from this one single-cell organism all the way up to who we are now, and has progressed through time and chance. Don't paint these people out as that. And please, give them ear. Please talk about these things. Discuss these things. And know this, don't be scared. You both come with a presupposition, with this idea of the makeup of the world. And that's how you interpret the evidence. The evidence is all the same. We're all looking at the same thing. We're just coming to different conclusions. Number 4 is this. Sorry I haven't gotten into the word. I'll hit you with some verses at the end. But the 4th thing is this. The 4th thing that you should know when discussing evolution, whether it's in school or not, is this. The difference between operational and historical science. So the first one is this. Science does not equal evolution. The second one is this. It's a battle of the worldviews. It's all about the worldview that you have is how you're going to interpret the evidence. You have to check your worldview. And the third thing is this. We don't serve a God of the gaps. The 4th thing is you have to know the difference between operational science and historical science. Operational science is defined as this. It's a systematic approach to understanding that uses observable, listen to this, observable, testable, repeatable, and falsifiable experimentation to understand how nature commonly behaves. Okay? Basically, it's like I just said. You're looking at the evidence, you're making observations, you can test your observations, you can have repeated sessions where you test this theory out, and it could be falsifiable. It could be falsified by someone else who comes along and says, I did that same thing and it didn't work out. And you can go back and you can redo it and restructure it and figure out what's going on and why this maybe didn't work. And it's just like progress of seeing how things work, and it's in the now, it's in the here. And this is kind of operational science is where we get the things like cures for cancer, where we get medicine. Okay, this is observational science. This is where my man, what's his name? I can't think of his name. He mapped the genome. He was the president of the genome project. Man, I can't think of his name, but it's okay. He's looking at DNA and he's making observations about DNA. And it can be testable. It can be tested. So this is observation or operational, also known sometimes as observational science. Here's the second thing, is historical science. This is where it gets a little tricky, and this is where kind of the realm of the worldviews collide and hit. Okay, and this is what you guys need to know. Is that historical science is this, interpreting evidence from past events on a presupposed philosophical point of view. Basically, it means this. You look at something and you observe it and you say, okay, well, this looks like it was dated about here, or you test it and you're like, I think this was dated back here, and then you make observations about this thing that's here in the present. And you bring your presupposed, this is how I think the world used to look. Even though I wasn't there, this is what I think it looks like. And this is what the observation I'm going to make about this thing is. I'm going to make judgments about this moment in time based on what I'm seeing here. This is where it gets tricky, because I think you can make some pretty good observations. You look at archaeology and things like that, man, those things are indispensable. When it comes to evolutionary biology and things like that, it gets a little tricky, and there's a lot of different viewpoints. And you guys know that. You see it on the news all the time. By the way, don't believe half the things you see on the news, and always be careful, because they always choose from both sides the craziest people. All right? And you're like, that person is just talking and talking, and okay, they're like, here's Pastor Joe and here's scientist blah blah blah, and they're like, and it's like battle of the minds, and you're like, that guy's not even saying what I believe, what most Christians I know believe. What is he doing, So, news is always going to do that, like put a spin on things and make this person out to be, the crazy person, and this person to be the sophisticated person. And sometimes we do that to ourselves, by the way. Okay, but just be careful. So you have to know the difference between operational. Me, I'm down with operational. Now, whenever I say that I'm not an evolutionary biologist by any means, I'm not saying that I'm not interested in curing cancer, and I'm not interested in mapping the DNA, you know, mapping out the workings of your body. I'm not saying that, man. That's awesome, man. There's a lot of good things that come from that, and I'm praying one day that some of you guys go into that field, that you guys become scientists who observe things and create things, and I think that's what God made us to do. I'm going to open up the scripture right now because I shared it with you guys last week. It's just Genesis chapter 1, verse 28. Just really quickly, it says this: Then God blessed them, and God said to them, this is after God created man and woman, and he said, be fruitful and multiply. So have sex and have some babies. Okay, fill the earth and subdue it. So this is what I talked about last week, is fill the earth and subdue it. Cultivate the earth. God's given us the 5 senses. He's given us our eyes to see, our ears to hear, our fingers to touch. You know, our whole body's filled, you know, but, you know, he's given us all these things. And the reason he's done it is to cultivate the earth, to go and be creative, to show God's image in you by creating new things. What did God do? The beginning says, in the beginning, God created the heavens and the earth. That's the first verse of the Bible. The first stinking verse of the Bible. The one thing we observe about God is that he is and that he created. And then the Bible says that God put his image in you and me. He made us creative. He made us to create. He made us to come together, cultivate the earth, to figure out, man, how did you make this, God? How did you do this? To have this sense of awe when we look at the sciences. So, that's the fourth thing that you should know, is the difference between operational and historical science. Historical science is mainly where the disagreement comes in. There's operational science where, you know, there's like stuff like testing embryos and like human embryos and stuff like that, which comes into like moral issues. But that's like maybe not even 1% of like operational science. We can have discussions about those type of things as well, but as it pertains to operational science, it's a go. Historical science is the place where we would say, hey, just look out before you make observations. Hey, were you there when this happened? When you're saying this happened, were you there? It's okay to talk about these things, discuss these things, but be careful, basically. So knowing the difference between those two things is very beneficial. And the fifth and last thing is this. I'm going to give you 3 terms. I'm going to explain them briefly. You can write them down and search them out yourself, okay? This is not meant to be some exhaustive like science class or something like that, or like end all on scientific theory and stuff like that. That's not what this is. Here's the 3 words. And I'm also going to help you guys memorize them using 3 things that we know. Here's the first. Interdependence. You've probably heard this in science class. Interdependence. Here's the second term, is irreducible complexity. And the 4th term is fine-tuning. All right? So here's the way that you're going to remember the first one, irreducible complexity, or it's probably the second one, but it doesn't matter. Irreducible complexity, this is how you're going to memorize it. Think of a microscope. All right, a microscope. All right, we use microscopes. That's how, you know, the mapping of the genome, the human genome, mapping out the DNA in a person. That's how it's done, is through microscopes. They look at and they see the intricate detail of the cell. And each part of the cell, listen, this is what irreducible complexity is. When you look at the cell, okay, back in the day, whenever the theory of evolution first came, we didn't have microscopes that were powerful enough to observe a cell. You know, for all they knew, it was just a blob. But since then, we've been able to observe through a microscope what a cell looks like. And we've been able to go through the years, the progress of science, we've been able to observe what a cell is made of. And there's important parts of that cell. And this is where the word irreducible complexity comes. Are you ready? It's this. It's like let's say a mousetrap. This is an example that this guy named Michael B. he used. He wrote a book called Darwin's Black Box. Anyway, and the theory, or his picture has been kind of rebutted and stuff like that. And I still think it's a good one. But listen, it's a mousetrap is made up of 5 important parts. If you are missing any one of those parts, that mousetrap is no longer good. That particular mousetrap, the way that mousetrap is made, if you're missing any one of those parts, your mousetrap is no good. And we've all probably experienced bad mousetraps. We've all probably experienced good mousetraps too, like at the retreat, the winter retreat, right? You guys remember that? Yeah, that was a good game. Anyway, next time we're going to do it with no shoes. And okay, basically, if you don't know, we laid out mousetraps and we walked, blindfolded, where someone led them through it. It wasn't too scary with shoes. It's definitely scary without shoes on, because you have to trust the person. So, all right. Irreducible complexity looks at the cell, and we say this, that you look at the cell, the way that it's made, if you were to take out one of those things, the whole system fails. That's basically what irreducible complexity. And what we say is this, that it looks, through this, it looks like there could not have been a single cell organism. It was really easy to say that back in the day. But now, since we've seen it, there's this irreducible complexity, and this part was needed for this part was needed for this part. We call that irreducible complexity. That's all I'm going to say about it, all right? So listen, this is your option between these two things, all right? The naturalist will say this, that the way that this cell has come is through a whole lot, this is what they need, a whole lot of time. A whole lot of time. And through a whole lot of chance. We look at it and we're like, man, there's no chance in the world that all of these things happen. Not only that, but they have to account for this, the information in a cell. That's good and all. You know what? I'll give it to you. You take a bag, you put all the parts of a cell into the bag, and you shake it up, and maybe one day you'll get a cell. Maybe one day. You give it enough time, you put it on the table, you just let nature do its work, and you come back a million trillion years, and you look at it, and you're like, all right, it turned into a cell. It did its part. Okay, if that's the case, that's cool. But in the DNA is information that reads like a computer. And there's one thing that you have to tell me is, where did that information come from? Why is there information in in this? I don't really like cliches and stuff like that and things that I hear all the time, but like I've heard, the Big Bang is crazy, because what it says is this, that basically you take scramble words and you put it into a bag and you shake it up and you throw it on the ground, and all of a sudden it's the Declaration of Independence. Now I'll give you this, that you throw scramble words onto the ground, you're going to find some that maybe line up to say words, but you're not going to see the Declaration of Independence that has all of these things put together, structured, and the information for the Declaration of Independence. You're not going to see that. But that is what the Big Bang says. That through time and through chance, like this happening millions of times, like all of a sudden, I don't care how many times you get it, you're not going to get the Declaration of Independence. When we say irreducible complexity, this is what we mean. Here's the second one. So that was looking through a microscope. Now let's, I couldn't really think of a good one for this one. But actually, I'm gonna skip that one and say it last. So I'm gonna actually say a telescope. So you look through a microscope, now you look through a telescope up into space. And this is the word that goes with that, is fine-tuning. All right, you've probably heard of this before, that, let me give you what Stephen Hawking says. Stephen Hawking is the guy in the wheelchair. I think he passed away just recently, but he says this. He's a really smart guy. If you've probably seen him. I think he had, what did he have? Anybody know? What? Cerebral palsy? Yeah, I think that's what it was. So, okay, listen. This is what he said. The laws of science, as we know them at present, contain many fundamental numbers. So he says there's numbers in science, and they're fundamental. They're needed. They're like the base work. They're the foundation. Like the size of electric charge of the electron and the ratio of the masses of the proton and the electron. So all of these things. And he says, the remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. All right? So not only that, but we have this. When you look into space and when you see the way that the universe is created, I'm going to show you two options for this one as well. You see stuff like this, that the strong and weak nuclear force, the constants, you see the gravitational force, that it's a constant, that if it were to change just a little bit, life on Earth as we know it would not be possible. You see the electromagnetic force, same thing. If it changed just a little, that would be it. The world as we know it would not, it wouldn't be able to support life. So we see almost that the earth is the only place that supports life. And we call this fine-tuning, that these things don't just happen by chance. You know, there's this thing that once you get to so many different variables, it's like things are called impossible. Like, this will never happen. And that's what it is, because there's like 34 different things like this, where it's like, that couldn't just have happened. If this one knob turned a little bit, everything else goes. So, this is the fine-tuning argument, is basically that we believe that someone fine-tuned all of these things to make the world work and the earth to support life. So it's either this option or there's another option. The naturalists would say this. Again, they would use time and chance. They say, well, as long as you have enough time, eventually, with all, they call it the multi-universe, the multiverse, that there's millions of universes, that there's millions of universes that you can't even count, that with all of these universes, eventually, there's going to be one that supports life. That's why we're looking for other ones to support life. I'm not saying that that's not possible. Like, I'm sure that God could have created another place that had life, you know. We don't know about it right now, but, you know, I'm not saying that's not possible. I'm not throwing that out, but we don't find it yet. You see that the earth is made to support life. And they say, well, through chance and through time, eventually this could happen. So my question is, which one is it taking more faith to believe in right now? Is it that there's like lots of time and chance eventually this happen? Or is it easier to believe that there's a God who created these things and fine-tuned all these knobs and made this work? Which one does it take more faith? I'm not gonna lie, it takes faith to believe both of them. And that's my point. My second point was that it's a worldview that you hold. Which one do you believe? Which one's easier to believe? So you see that in the irreducible complexity of the cell, but you also see it in the fine-tuning of the universe when you look through a telescope. The next one I used was a magnifying glass. That's the best thing I could think of. I thought of like a detective going around the earth. Well, you see that word interdependence. Basically, you look at ecosystems and you see that each part of that ecosystem is needed to support the other one. Again, what they use is time and chance. So basically, that's it, the ecosystem, looking, and it's interdependence, that without this organism can't survive. Which one came first? Did they come together or what? What's that look like? So we believe that God created these two, and you know, that's just it. So that's the fifth thing, are those three words. And like I said, that was not meant to be exhaustive. That was meant to be quick so that you guys could go to small groups. The first one is this: science does not mean evolution. The second one is this: there is a battle between worldviews. The third is we don't have a God of the gaps. God's not your crutch, don't worry. The difference is, this is the fourth one, you need to know the difference between operational and historical science, and the fifth one is this. You need to know those three terms: interdependence, fine-tuning, and irreducible complexity.